Let me make a recording of this session so that way it is preserved for posterity's sake. And I started the recording after the birthday jubilation, so one member will be very happy. So it's good to see everyone here. Any other observations, questions from the group? Ideas for things we should do? Maybe you want to hold an event here at a virtual event where we get more people involved. Sorry, when you get older. There we go. Cleaning my glasses. That's like a Dell wants to join coding competitions. Honestly, there are some. I'm so bummed that this competition did not happen while this club was going on. It actually, it cut me deep. Let me see if I can find it. There was a competition. That we would have rocked. I'll share my screen. This is the person, I believe, who actually ended up winning it. And I'll share my screen so we can all see. But I was bummed because between all of us, it was actually the type of competition where we could have, as a team, done very well. Andrew NG, you've heard me mention the name repeatedly because that's one of the stalwarts of the AI movement, actually one of the founders in many ways. You can see there was a competition. Here's the little promo, the Datacentric AI Competition. And the idea is all too often in the data science realm, we've focused on tweaking models throughout the process. How can we better make this model perform? What can we do to this model? You just rephrase it and use the word model. But Andrew NG is trying to promote, and others have too. I shouldn't just put this on Andrew NG, but recently there's been more work to address what can we continue doing to the data in terms of data engineering. What can we do to continuously make us, what can we do to improve our results, to essentially achieve a better model by continuing to engineer the data? And so this competition, the model was frozen. You couldn't choose a different model. You couldn't tune this model. The model was frozen, and the only thing you could do was manipulate the data. I say manipulate, some people might be getting and rightly so, you're thinking, whoa, you're just trying to get an answer. Well, when you have vast amounts of data and you're engineering that small amount to better answer the incoming stream of data, you're willing to do what it takes to just get better results. And this isn't a research project per se. This is just working with a model and trying to develop a model that is best predictive. And sometimes the best approach is to work with your data and tune it. So let's look at the examples. This person won it. Notice they say most innovative award for data boosting technique. Now, innovative does not mean best performance. The individuals over on the left side obviously won for best performance. And that was a large team, notice. But most innovative, there was a data boosting approach here. What we had just images of Roman numerals. the only thing you could do with your training set was either throw data out, you could get rid of bad Roman numerals, you could perhaps clean them up, you could perhaps augment your training set, you can add new cases, but you were limited to 10,000 total images. I forget what their initial count was. So you were given 3,000 images, and the intention is you would be limited to a maximum of 10,000, and you could do whatever you want with those training images, with the intention that once you're done, if they used your training images, your results would actually perform the best on the data that we didn't have access to. Now, here's some examples. Image. I actually played around with this competition. And as I did so, I was thinking, gosh, why can't the AI Club be meeting now? We could work this would be the perfect project. But its timeline, essentially, it stopped just as we were starting. Now, this write-up I will toss in our chat. So if someone wants to go, this is a data boosting technique. You can read more on that. I'm not going to spend too much. Oh, I don't want to direct messages. I will share the link. You can always go read that. But my hope is that they have another data-centric competition. I've been watching. And if they do, we're in on that, Del. I will work over the weekend. Still got to clean these things, and we'll make that happen. We will go for the win. So the point is, there are competitions like this. That said, because we use so much Python, at least as of yet, if there was, I would say if there was a coding competition that was focused specifically on Python, I would be in for that. I don't know about others in here, but my hope is, and I've talked to others in here about it, I'd like to see us do more to develop more skills in terms of Python coding specifically. Yeah, Del, competing is a good way to learn and be motivated. I absolutely agree with that. I think that's true for all of us. So I'll put that out there to all of you. If you find a Python coding sort of competition, just know some of them are going to be more advanced, and we probably want to find one which is sort of middle ground. And if we can do that, that'd be a great competition to be in. Now, I've been sent some videos by people who are instructors elsewhere in the college. This one was sent by Simon, one of the adjuncts here at LCC, and this is just a video with very short video that covers machine learning. It says explained in 5 minutes. I like the idea to reinforce this. So let me reshare my screen so that way it's actually optimized for video, and let's watch this. Now I'm going to refresh it because it's giving issues.
Hey guys, Jade here. So you've probably heard the words machine learning a lot in the past few years. And today I just wanted to talk to you about what it actually means. So a lot of people think that artificial intelligence and machine learning are the same thing, but they're actually not. Artificial intelligence, or AI as the cool kids say, is the entire field dedicated to making machines smart. Machine learning is a division of AI. And it's really cool because you don't actually have to program the machine to do what you want. It improves or learns by repeating the same task over and over again, slightly tweaking the process each time until it's doing exactly what you want. It's similar to how a person learns from experience. So to give you an example, imagine your grandpa works at the local grocery store. His job is to sort the apples from the bananas, but he has a bad back and complains all the time. So you want to program a machine to do this job for him. The first thing you do is define some features it can use to distinguish apples from bananas. One might be color. The redder the fruit is, the more likely it's an apple. The yellower it is, the more likely it's a banana. This is a pretty good starting point, but what if we encounter a situation like this? Obviously, color isn't enough. We need another feature. Another good one might be hardness. The harder the fruit, the more likely it's an apple. The softer, the more likely it's a banana. We can choose a lot more features, but let's keep it at 2 to keep things simple. Now that we've defined some features, we need to collect some data to train our machine. So you go and get 50 apples and 50 bananas and label each one as item 1, item 2, all the way up to 100. Then you measure the color and hardness of each one, note down whether it's an apple or a banana, and feed your data into the machine. Now it's time to test it out. At first, it kind of sucks. Even though it's got its 2 features of color and hardness, it doesn't know how much importance, or as computer scientists say, weight, to place on each of them. The idea of weights in making a decision is probably the most central idea in machine learning, and it's something we're all familiar with. Say you're looking for a romantic partner, and 2 things you're looking for are intelligence and a nice smile. But maybe you place more weight on intelligence than you do on a nice smile. But also, if they never smiled, that wouldn't be good either, so you still place some weight on a nice smile. Weights play a huge role in any decision. That's why when your friend tells you they've found you a good match, they're usually always wrong. They may know what features you like, but they don't know the weights. What separates machine learning from previous forms of artificial intelligence is its ability to figure out these weights. It does this by comparing its results to the data that you gave it. At first, your fruit sorting machine distributes the weight randomly. It starts with item 1, which happens to be a very unripe banana, which is of course much harder than a regular banana. If it places too much weight on hardness, it'll be like, okay, it's hard, so it must be an apple. But by comparing this to the data you gave it on item 1, it'll realize it's made a mistake. It readjusts so that less weight is placed on hardness and more weight is placed on color. But it overshoots, and when it encounters a yellowish apple, it wrongly classifies it as a banana. But again, by comparing its results to the data you gave it, it realizes its mistake and readjusts the weights again. It repeats this process of comparing and readjusting until it's barely making any mistakes. After some time, it's ready to take your grandpa's job at the local market. This example was a simplified version of what Facebook is doing when it tags you in a photo. Facebook learns your face by analyzing photos which it knows are you, by measuring the size of your eyes or the length of your nose, and it uses this data to identify you in the next photo. Actually, machines are getting pretty good at this. In 2015, a robot beat a human at image recognition for the first time. And now they're developing robots that can clean your home for you. How cool is that? If you'd like to know more about how this weight adjusting process works, make sure to subscribe to Up and Atom so you don't miss my next video on neural networks, which is really where all the magic happens. So yeah, until next time, have a good day.
All right. Right, the grandpa, I appreciate the humor. that helps with all these types of presentations. I'm going to put this video in the chat so others can bookmark it, watch it later as you'd like. But an excellent video. I think that's a very nice resource. Thoughts from that? Jessica says, good video. So it makes an important distinction, and it's consistent with the other resources I have in the sense that AI is the umbrella. AI is where you say, well, we have all those possible types of tools, technologies. For instance, expert systems are a form of AI, but that's where we have experts who actually try and impart their knowledge to a system. And that's the machine's not learning in and of itself. We're trying to share what's already been learned by another person. Expert systems are one component of AI, very different from machine learning. And typically in machine learning, a subset of machine learning, that's typically where you'll see we actually categorize neural networks, deep learning. So, yeah, I love that video. I think it's great. And Grandpa, shouldn't have complained about your back. So let me stop sharing here for a second. I do have, well, actually, I'll keep sharing and let's just go through some other resources if it's okay. I'd like to point out some things. I actually, let me put this in the chat. I have this text. So genetic algorithms and machine learning for programmers. I was tempted in a future session, we might work through a little bit of this. It's the type of text in which you build things up essentially from scratch. You aren't so much leveraging libraries as you are developing code which integrates genetic algorithms and machine learning principles. A little bit more in depth in terms of the coding, but not a lot. It's straightforward enough where I think we could do it. But I put this out there. I think this is a very nice resource. If you have a chance to check it out, there are actually some excerpts you can get down here for free. So for instance, code your way out of a paper bag. People have told me I can't dribble my way out of a wet paper bag, but apparently I can code my way out of it. Boom, create a genetic algorithm. That actually is one of the chapters I think we could work through and have a fun time working through it as a sort of a thought experiment related to genetic algorithms. The idea is from scratch, you're coding up an example which leverages a basic genetic algorithms approach. Here's the PDF. Let's make it so you can actually read some more of that. So you can download this for free, this excerpt. And I think there's also a code download that has the corresponding source code for this. I say check it out. We have some type of fitness function that we then use to determine, it's what's actually looking for the best possible answer. And if you come up here to the top of that original page, we can see the source code is right here for download for the book. I encourage you, check it out. I know, funds are, this is a tight season in terms of funds because Christmas is around the corner for many of you. And so, oh, Natasha, it's a pleasure to meet you and see you here. Have a wonderful day. So this is something that I think we could work through and perhaps work on that specific implementation. Let me stop sharing my screen. I'll see if I can find the code so you can see an example of it if you're interested in this. Let's see here. Here we go. I think I found it. So let me share my screen. And let's take a look at this code. So for instance, this is some of the code that would be put together as an end result solution for what's found in that chapter. You could certainly take liberty with this code though and make some adjustments. But notice it's not that much code, and it's actually working through a nice example of a genetic algorithm sort of approach to solving, to finding a solution. Typically, we think of some models, algorithms are used to make predictions, that type of thing. Genetic algorithms, you're trying to find some type of solution, the best solution that can be found for a particular problem. So we might work through this at some point in the future, but the thought was that's a neat text. It's a neat idea. And I like that it has you work from scratch. What do you think? Is that something that might be a future interest for us? So Jessica says, sure. James, yes. All right. We'll see if we can do some more of this. I like genetic algorithms, I think. So Jessica says, what compiler do I use? Well, for this, Python, we typically leverage the interpreter. You can download, for one, much of this, Jessica, actually, we could just run up in those collaboratory, the IPython notebooks that we've used before. That said, you could download Anaconda, or if you download VS Code, so Visual Studio Code, that has some nice integrations for Python that make it very easy to configure Python. I was sharing my screen. This is VS Code on Windows 10. So just to head back here. This is VS Code, and it makes it very easy to set up and configure a very nice Python environment. Notice at the bottom, I don't know if it shows up, but you can see Python 3.8.8, and you can see virtual environment. It's very easy to get something up and running in a way where it's isolated and doesn't impact other perhaps Python installs on your system. So VS Code is actually one of the tools I do recommend to students. It's very easy to set up. It's very clean in terms of the interface. It's still very powerful because of what's available. What the plugins that you can install are just fantastic. What do you think, other people out there? VS Code? Pretty solid for people in terms of editors. I love VS Code. I think it's, I'm curious if people want to put in the chat, what do you use? So Jessica's using Visual Studio for C++. Excellent. Visual Studio for Steve. If you're doing a lot of C++ programming, Visual Studio is pretty great, I have to say. PyCharm and VS Code. Yes, PyCharm's great also. And James, you downloaded it. Yes, Sublime's very nice too. Yes, I like all of those actually. I'm an eclectic coder. So, and Dell uses Sublime typically only on Linux though. Hey, on Linux, Sublime is, that said, I believe VS Code, does VS Code also work on Linux? I think it does. I haven't actually used VS Code on my Linux distros. I don't typically, so Dell's saying yes. That sounds right. I think I perhaps tried it out just briefly. So let me share some other things with you while we're having a peek around. I don't know if you realize, but there are open educational resources that are available for free in book form. Let me share my screen again. And let's have a look. Because I want you to know that you can search for things and find, for instance, I found a natural language processing text that's free. So let me share my screen. So I want you to be aware of Pressbooks. Pressbooks is actually something that LCC is affiliated with too. Dell, you asked when I'm going to write my book. I've considered writing a book for this location, actually, for Pressbooks. This is a unique offering. Let me toss in the link. Actually, I should. Let's head to the home page so you can. So let me share this. Pressbooks is a location where people typically post open source. So if you're thinking what you typically use to declare something open source in the published realm, it's Creative Commons 4.0 type of license. Open source materials that you can share in any form of media. I can even augment these materials and make edits that supplement it or perhaps simplify it for purposes of my class. So let's find an example. You'll say I already had done a search, but let me search for artificial intelligence. Now this is asking a lot of this service because that's a very new field. Most of the resources are resources that you have to pay for. We see some things of interest. So for instance, ethical use of technology. The ethical implications of AI are pretty significant. We can't study AI unless we're willing to put in a significant amount of time assessing the ethical issues that are inherent with this approach. That seems like a reasonable resource. I'm not sure why this one is included. But this one, unmanned aircraft in the cyber domain, I can see where this is. Unmanned aircraft are that's the union of artificial intelligence and cybersecurity and so many other things, that's probably a very interesting read. This is free. You want to read this? You can just go read it. You can even edit the book and make revisions as long as you always give credit to the original authors. But here's what I found of interest today: principles of natural language processing. You'll see this come up a lot in our, for instance, that text that I always talk about how much I love, hands-on machine learning with scikit-learn, Keras, and TensorFlow. NLP is brought up in this. There are some examples. And so if we dig into this, we can see, here's the text. You can just read it online for free. Now, it's a rather sophisticated text. It's covering this at a rather high level, but I like right up front here. So for instance, let's see, let's find something that's more approachable. So one thing that you're dealing with in natural language processing is ambiguity. The idea that something can be interpreted in more than one way. So for instance, read the pun on the left there. Our pet duck keeps biting everyone, so I bought a cheap muzzle for it. Nothing flashy, but it fits the bill. Well, if you're interpreting that as a machine, you have a couple different ways of doing so. Fits the bill is an idiom, so it could be that it just means, hey, this is suitable for the purpose. That's just a phrasing that we typically use to mean suitable for the purpose. Or fits the bill could mean, as a compositional expression, the right size for the beak of the duck. Now, given the context of this, and given the fact that you're machine learning this whole thing, you can see where ambiguity might cause significant issues. It does. It's been quite difficult to deal with. That said, the corpus size for the natural language processing models out there keeps growing. Corpus is just all the text that's used to train it. And additionally, we keep enhancing our methods. Right now, transformers, you heard me mention this a couple of weeks ago, but transformers have gained a lot of steam. We now can produce natural language processing models that are incredibly sophisticated. Doesn't mean they're perfect. Guess what? My language processing isn't perfect. It's far from it. Ask my elementary English teachers. So it's neat to see these types of resources. Let me just make sure this one in particular, you have an entire textbook. I tossed that in the text chat for everyone to bookmark the link if you desire, but you have an entire textbook free that covers NLP. I love it. Have any of you had any experience with natural language processing prior to this exposure? For instance, have you played around with any of the libraries, or have you at work had to do this type of, or help with this type of analysis? Okay, if no one has, I'm just curious if there's someone else who can bring other materials to light. We're all about that. So not seeing anyone who's actually done this before. I had to do a little bit I'm hesitant to share, but I like singing online. I like online karaoke. Everyone has their vice. So James says, just got familiar with the term and computer vision. Would love to see some code examples. We're gonna do this, James. I guarantee. In fact, I'll tell you what. James has asked, I think, a couple times about the vision related aspects. Let's plan on next week doing our first foray into the vision side of AI, specifically machine learning. Does that sound like a plan? So next week, let's plan on doing some vision. We'll just explore. Not going to do heavy lifting. We'll do some coding, very basic, but we can look at some tools and see what we can get started with. Now, there is a data set for this week for coding purposes. There's a data set that, gosh, it's just practically ubiquitous in the realm of data science, machine learning, anything data-y. The Iris Dataset. Now, we could start by just jumping right into the code and doing things, but I'm sorry, I like to understand the provenance, and I really want to impart the idea that it's important to have as good an understanding as you can of the data, where it's come from, why it was collected. This informs our understanding of how we can use the data. That's part of the ethical component too. Know where your data came from. Know how it was collected, why it was collected, what was collected. We need all of this information if we're going to try and create models using these algorithms that espouse ethical considerations that are consistent. Now, this data, let's look at that picture. That's beautiful. But let's jump to the text. Let's see if I can make this. I know normally you have the magnifying glass you can use, but I'm just going to make it a little bit bigger. Now, is that a little bit more readable for everyone? Let's work through this. We'll be fast. This Iris dataset, I'm telling you, in graduate school, I used it. Well, actually, both graduate schools, both at Central Michigan University for experimental psychology, and then at Virginia Tech for machine learning. It's just a very frequently used data set for anything data related, but especially machine learning. It's very clean. If you're there we go, James, fire up chips. If you're trying to get students started in an area, you don't want it to be a sloppy data set that takes an incredible amount of work just to get started. That's not too fulfilling. You lose inertia fast. This is a clean, clear data set, which also, in terms of provenance, it actually has a very cool person at the helm here. I'm just going to read this paragraph from this article. Let me share the link to this. I don't believe I already did. I'm old and forgetful. Remember, towards data science, for some of you, if you view too many articles, it doesn't let you view it for a while. It has a limit on how many articles you can view for free. I've paid for it, so don't worry. I can show it on my screen, even if you use up your limit. But here, just generally, this is written by Young Q, and Young points out the iris flower data set is also known as Fisher's iris data set. Your guess is right. This is the same Fisher, Sir Ronald Fisher, who also invented Fisher's exact test. As a fellow of the Royal Society, Sir Fisher was born in 1890 in London, England, and was a well-known statistician and geneticist. It says his contribution to statistics is way beyond Fisher's exact test. For example, he developed the maximum likelihood estimation and the analysis of variance. Now, let me tell you, I'm sure some people in here, knowing your backgrounds, have used ANOVA. This is the dude who's actually responsible for a lot of that. If I remember correctly, let me come back up here. It seems as though, if I remember correctly, Fisher actually lived in Michigan for a short time. So I think we have a claim to fame there. But ANOVA, analysis of variance, essentially what we need to know for ANOVA is that you're coming up with two estimates of the mean using different approaches. And because you use the different approaches, they both should be the same mean if you're using both and they represent the same population. But these different approaches, they have the value that if you come up with an estimate of the mean and they don't match, sometimes it can reveal that you're dealing with real or significant differences in populations. And so we use ANOVA all in the psychological world. We use ANOVA all the time. Experimental psychology, that's just one of the primary tools. MANOVA, MANCOVA, they're all related. But let me just read that quote. For his work in statistics, he's been described as a genius who almost single-handedly created the foundations of modern statistical science. Yeah, he was pretty cool. Well, look at all this work. Iris Setosa, Iris versicolor, Iris virginica. You see all of this painstaking. Someone had to collect this data, all these measurements. That's what Fisher did. And we can see frequency histograms of the discriminating linear function for 3 species of the iris. Fisher actually put this together. We don't have to draw this out. We can actually perform analyses on this data and use our algorithms to train up a model that's very capable in terms of making predictions between these flowers. Where are they? I went the wrong way. Here we go. Iris setosa, Iris versicolor, and Iris virginica. Sorry for those of you who are botanists and I'm butchering the names. So notice there are certainly similarities between these, but yet there are differences. They are different species. So we can use those differences to actually create a model that makes very good predictions. Now, this is a classification question, right? This isn't regression. Regression, we're predicting a value, for instance, how much your home will sell for. In this case, this is like the Titanic question that we dealt with before. Which one of these 3 classes does this particular specimen belong to? Which one of these species is represented? We are trying to classify. Now, this final section just points out it's really important to understand our data, both the provenance, the what, where, why, how. All of these things are important, especially when we consider ethical ramifications. So enough talk now. That's the data set. What you can see is if you Google, I just Googled Iris Dataset, you're going to be inundated with tons of stuff. Literally, probably thousands of references and resources to people playing around with this data set. It even has its own Wikipedia entry. Come on, that's saying something. notice it's built right into scikit-learn. This right here, we don't even have to go to a URL to get this data set. It's already present. Now, we certainly can, there are certainly locations where you can get it. For instance, right here, UCI machine learning repository, I've actually already pointed to this particular location. You could download it. Here's the data folder. And you could work on it locally. We don't have to do that. So I just found an example. This is by Dihao Zhang, and this particular walkthrough talks through several different techniques that could be used. So first things first, this individual actually posted the code so we could just follow along in GitHub. So I encourage you all, we have just a little bit over half an hour. Let's open up here. I'll start from scratch. If you come to collaboratory, so this is the link. Remember, sometimes we don't even have to install things locally. We can just leverage resources up in the cloud. So I'll give you a second. Go ahead, open that up. And when you get there, we're just going to start coding. Notice it says, you know, things I've done already. You see some AI Club references here. I'm going to open a new notebook. Now we could just work directly from the code of the GitHub, but I want us to copy and paste things as we go. And hopefully that allows us to walk through and make sure we're understanding what's happening as we work through it. So I'm going to title this AI Club. And so it's 2021, 11, 16. So put a Y in chat if you're actually at a computer and you're ready to do this, or put a Y in chat if you're just not going to do it, but you're all set to follow along. Those who want to work though, let's just start coding some stuff. Sometimes you just got to break things. Not that we're going to have any syntax errors or any issues in our code, right? So I see 3 are ready. All right. Let's start to slowly work through and see what we can do here. So first things first. Again, I'll paste this in to the chat. This is the GitHub. Now, notice, first things first, as I did in my example, it's typically of good form to import everything that you're going to be using. Of note, you don't have to import these things. You could just always type pandas. You can actually use the full name, but that's not typical. That's not actually considered very Pythonic. Typically, you import things and use these names specifically: PD for pandas, NP for NumPy, SNS for Seaborn, PLT for Matplotlib, PyPlot. All these have conventions, and it makes it much easier when we want to use them later. We don't have to type as much. We're lazy. Well, I'm lazy. You're not lazy. Now I'm going to head back over here and paste that in. If you remember, from last time, you have a few ways you could run this. You can click over here and just run that by clicking the icon. I typically use the keyboard shortcut. I say Shift, return, and it runs that first block, that first cell. Notice I have a little check mark, green check mark. Yay. Now all of those are ready for being used. Let me just quick talk through this while you're doing that. Pandas, we've already used pandas. NumPy, very capable math libraries, typically speed up the performance of matrix related work. Seaborn, very good for graphical display. Matplotlib, same thing, display of the data. sklearn, scikit-learn's great for actually providing the models that we can train up the tests. Pandas, very convenient for working with data sets. In this case, it doesn't look like they're using pandas too much. It's fine. We could always change it if we wanted to. Let me head back here. Now notice, again, I noted we have access. You can just load the same data set using scikit-learn. You've already got scikit-learn. You could just load it. But let's follow their conventions. I'm not sure they knew that they could load it this way, or maybe they're showing the example how you would get it if it was a remote data set. That's probably what's going on. So let's paste this in. We did something very similar in our Titanic example. Again, I'm going to hit Shift Return or Shift Enter. And so far, so good. So we have a URL. Notice we defined, we labeled the attributes ahead of time. That's sometimes very convenient. And we read that in as a data set. And of note, we added names here. We actually set that to attributes, that list, Python list. And that's what's allowing us to actually inject the names. Now, if we run this, also the columns we set to attributes here too. Now let's go to the next cell. Notice, remember what I said last time, if you want something to be displayed, our books, these IPython books that are up in Collaboratory, it's really convenient. I don't have to copy and paste that. If we enter a value that's just a value, we're not doing anything else here in the code, it knows, hey, you just want to see this thing. So when I just enter data set in a cell by itself, no problem, James. When I enter data set here by itself, it just displays, remember, it gives us this pretty output. I could do that, I could print this as we talked about last time, but notice it's not as aesthetically pleasing. These notebooks automatically display a very nice HTMLized format. And notice there's a hover effect. It's easy to see all the rows, etc. Notice it has the attributes across the top for the columns, class, Iris Setosa, Iris Virginica, etc. Also notice there are 150 rows. Now you also, this actually gives the example. If you downloaded this as a CSV file, you could also read it this way. We don't need to do this for our purposes. We don't need to grab the CSV file. We've actually already imported the data set. It's all set up. It's a data frame. And so we can skip this step, but we do want to remember that we have the head method that we can call on this. So let's see. So data set. Now we can set this number to any number of rows that will be displayed from the beginning. I'm going to set it to 10. And there we go. Just one more view. Notice again, I did not have to actually print this out. Again, the notebook just knows if the last statement in a cell is purely just a value, it displays the value in its pretty form. So, James, we're just creating a notebook. And so are you caught up with us? Are you all set that way? I don't want you to get left behind, James. All right. So I'm going to head back. Actually, let me put these links back in the chat. What we were doing, someone else just came in. We were looking at a GitHub repo that just walks through the Iris dataset. Here's the dataset. Because someone else just came in, let's make sure. This talks about the dataset. And here's where you could download it, but it's also included directly within scikit-learn. And now we're using that GitHub repo, which actually is written about here. So I'm just catching up people who came in. And so we just using Collaboratory, which is a free notebook in the cloud that Google offers us. We're just using this to work through this example. Now, remember from last time, we can look at the data types pretty easily. James asked, is Iris the computer vision data set? Not in the form that we're playing with. I suppose one could make a computer vision data set with images, corresponding images. The one we're playing with, we're just looking at the measurements of the petals. So there's certainly, people might have actually gone back and added to it, but its original form didn't include photos. It would be easy to turn it into a computer vision problem if we wanted to supplement it. Now, so D types is something else we can do, and also describe. So let's try those. But remember, we're using data set because we didn't. That's what we actually called our frame. So float 64. Those who have programmed before, a floating point, 64 size, that makes sense. Class is an object. In this case, it's a string object specifically. And so this all makes sense. And we can also describe it. And when we do so, we see a count. We see mean, standard deviation, minimum, maximum, percentile. Of note, when we look at these, they're all the same units. Like we're all on the same page there, right? They're all the same units because they're just measurements. But there are differences in their ranges. Notice the length of the sepal. This is min 4.3, max 7.9, 2, 4, 1, 6, and 0.1 and 2.5. I bring that to your attention because that's going to be something we should consider very soon. We can see how many we have of each species by issuing this type of command, the group by and then size. In this case, I'm going to say class because we renamed it. Again, just to avoid any potential confusion, when you look at this, you see there were two ways that you could get this set up. Earlier, it was called Dataset, and we had it set up with class, paddle widths, simple. Here, they were assigned differently. Later, this individual actually used a CSV file just to show you could also do it that way, but this time went with the standard names, and species was the original. That's the column name. So I'm just bringing this. That's why instead of saying species here, we're saying class because we went with this original import right here. I didn't have you all download the CSV file. Now, of note, there are some cool examples of this right through the scikit-learn website. We're just a brief detour here. Look at this. If you want to see a 3D representation, I just think that's pretty cool. This is, to me, quite beautiful in terms of its display and how you can see everything laid out. And all of the code is right here on the scikit-learn website. I just think that's quite brilliant. Notice again, as I said, they actually have a function. If you import the scikit-learn datasets, you can just say load Iris and it's there, but we didn't do it that way. Just know it's built right into scikit-learn. So I'll return to where we were working, but I just want you to be aware there's so many resources for this. Now, next, in this example, they create a train and test. Remember, you typically create one, you break up the data into groups that you can use first to train, and then you can test and see how well you did. Well, we have functions, actually this one specifically, the train test split, that makes it pretty easy. And so I'm just going to copy this instead of having to type all this out. I'm going to return to my notebook over here. Shift Enter to run it. Oh, and look, I was being hasty. What do I have to do here? Professors, we're old, forgetful. What's wrong with this? Let's use it as a troubleshooting example. It says named data is not defined. Then there's going to be another issue too. What do I have to do to fix this the way I copied and pasted it in? So Nick has the first one. Thank you, Nick. Thanks for playing the game. Uh-oh, I saw this coming. Yes, Dell had it. Thank you, Dell. We renamed it to class. Remember, that's what the individual did in their first example. And let's see. And I still didn't change all the data sets. Whoops, there's one at the beginning. So now let me carefully read and make sure I actually did them all. Yes, I did. Yay. Now we have a train and test set. We have one of each. We can train using the train set. And then once we're done, we can test and see how well we did. But I want to bring your attention to this. This is very important. Notice we had 50 of each. The Iris Satosa, Iris, etc., etc. We don't want to just take a random, completely random set. We want it to be stratified. And that's because we could end up getting all, if we break these up, you could have mostly Satosa, or you could have mostly Virginica. So stratify lets this function know, hey, we want to make sure this is a representative sample. We want random, but make sure you break up accordingly so that there's an equal representation of class in both the train and test. Does that make sense to everyone? That's the one tricky part here. Is that okay? I don't see any questions. So test size, that one should be pretty self-explanatory, 0.4, but stratify, when we're breaking things up, sometimes we want to make sure there's an equal distribution of, and so we can test this. Yes, we can just see here. I'll copy this. I won't paste it directly. We'll make some changes. I'll speed up so we can. And you see, we have 30 of each. This makes us feel very good. Now, let's head back. Histograms, we love histograms. Let's go ahead and just paste this in. I'm not going to do all this stuff. We'll skip some of the visuals because we only have so much time. But again, let's walk through what's happening. Bins, how many bins do we want? For each of these, we declare this variable once, and then that way we can just, instead of having to type 10 and all these, if we decide to make a change later, this is just good coding practice. If we decide to make a change later, we only have to change it in one spot. Then we set them up accordingly, and let me make sure it's not using any of the labels that are unique to our set. All right, here we see sepal length, sepal width, petal length, petal width. Really cool stuff. I'm going to jump down. I think I saw Seaborn in here. Yeah, we did right here. Let's go ahead and just jump down to what's labeled cell 15 here. I'm going to copy that. Paste that in here. few things. Remember, Seaborn is an incredibly powerful library that facilitates a lot of visual display work. A few things here. We see we're using the training set. We want to actually change this to class because that's how we labeled it for ours. Height to palette colorblind. Seaborn is an incredibly sophisticated offering, and this includes making it very easy to generate presentations that can be viewed by people who are colorblind. I love this. Now, this is going to take a bit. This isn't some chintzy little operation. There's a lot here to do. Look at that beautiful display. Notice we have the classes color-coded off to the right. Here's the legend. And as we see each one, oh my gosh, that's awesome. Look at the breakdown of the data. A tremendous amount of insights just from that one line of code. If you take your time to sift through this, you see some very good findings. Now, all right, James, I'm a little lost, but I like the visuals. So James, there are just a lot of ways that we can view the data we have so far. All we've done so far is we've loaded the data in a data set, and then once we loaded it, we set up a training test split that was stratified, which just means we want to make sure we break down our training and test sets so that there's equal representations of each class, each one of these classes right here. And now we're just looking at the training data. We're just taking a peek at what do we see? We should always spend most of our time when we're doing any type of machine learning work. It should be spent in the data first, looking around, seeing what trends we see, determining what might be our best bet for generating a good model. And so all we're doing is looking at several different displays of the data right now. Actually, we're going to jump here. Let's actually not just look at displays. Let's look at a correlation matrix. So let's make sure, okay. Had to make sure that, again, I always have to check. Make sure it's not using different names since we have slightly different variables in our notebook. Here's a correlation matrix. That just makes it very easy to see each specific correlation. So if we're looking at, let me get my draw. Well, this obviously makes sense, correct? We would expect sepal length to be correlated perfectly. Something will be correlated with itself perfectly. So this should be 1. That should make sense. Correlation just means as one variable moves, adjusts, how does the other? And what we see is, yes, length, sepal length and sepal length, as it moves in one direction, so the other perfectly responds. That's a correlation of 1. Something will always be 1 with itself. Here, though, we do see some interesting values. We see that sepal length and petal width are 0.82. That's a huge correlation. And sepal length and petal length 0.88. Those are significant. Those are big. Look at this one. Petal width and petal length. So there are correlations here. Now, sometimes we would consider, hey, these things are so correlated. Should we do some principal component analysis? Should we try and take multiple features and boil them down to a smaller subset since they're so correlated? That's something to consider in future sessions. We don't have to talk about that more now, but I want you to be aware, sometimes when you see whopping correlations like this, that's one of the things we'd consider. Now, let me clear all this and get out of the annotation mode. Now, I'm going to skip parallel coordinates. We've used a decision tree before. Let's go ahead and do these steps because one sec, my mouse is messing that up. Here we go. So let's come back here. Let's see if there anything I have to change. I have to change this to class. And I have to change this to class. That might do it. What did I do? Oh, that's going to pose an issue. Let's see here. What I'm going to do is I'm just going to cheat and go back here and run the whole thing again, but I'm going to replace instances of species, and I'm just doing this for time. I don't want to try and troubleshoot that. No, there are other instances that I should be changing. Where are they? Was the stratify. So we want this. We want this. I'm just doing this. Class is a loaded term. I think that's where we were running into issues. Could be wrong, but I'm just doing this to. Also, this will make it easier to copy and paste the work for the remaining. And again, runtime, we can say restart and run all. I don't have to run each of those individually. If I forgot to make some changes, it'll prompt me and say, hey, what are you doing, Adam? Mess some of this up. I would just fix it at that point. Ta-da, it works. Again, class, we'll get into that at some, I'm gonna save time here. Class is a loaded term. I can see why they went with a different label. So there are ways you can get around that in Python, but rather than do that, I just changed that. Now, xtrain predict. Let's have a look at a decision tree classifier. a decision tree can get a 0.98 level of accuracy. Oh my gosh. You always have to be careful of overfitting, that type of thing. Certainly not thinking of that too much right now with this little data set, but that's something we should always be considering when we work through this. Here you can actually see how important each feature was, but what we like to see, or at least what I like to see, maybe you don't like to see it, but I love to see this. And I was too fast. I must have forgotten to get, where is FN? Ah, that was created up above. So we'll just steal it. Now let's see, CN, and I didn't steal the CN too. Where's CN? There you go. I should have. So this is the haphazard. Let's just get this going. There we go. There's our diagram that lays out our decision tree. It's 12:30, but let's quick. I wanted to show you this one actually works through some other techniques. I know we've just done decision trees before. This has some others laid out here. For instance, a Gaussian naive Bayes classifier. We have LDA classifier, linear discriminant analysis. Actually, there's a nice write-up in the article on this. So remember, the article actually has a lot more details. Right here, linear discriminant analysis. And notice it even goes on to explain the difference between quadratic. You can get a visual understanding of the differences. Notice linear discriminant analysis, straight lines, breaking things up. Quadratic, bendy lines. This is the one that I like though, K nearest neighbor. Let's jump down to this. I love K nearest neighbor. Let's find this here and at least run this before you go. So let's try K nearest neighbor. This is where we say, what are the nearest neighbors to this thing in the training set? And whatever that is in the test set, that's what we'll make our prediction of. So essentially you say, let's measure in a 3, 4, 5 dimensional, whatever dimensional space that we're talking. Whoops. I thought I had that copied. Let's measure the distances. In this case, notice this says, let's try to take the 5 nearest neighbors and whatever they are, whatever the majority is, that's what we'll call this thing. And let's see, I'm making sure that. So a K and N, which actually in this case, the K is the number that you're actually comparing. You change it, it's a 5NN in this case, nearest neighbor. We're looking at the 5 nearest neighbors in this space and saying whatever they are, whatever the 5 nearest neighbors are to this particular testing point, we will call this the same. We make it odd, so there's a winner. And KNN 5, okay, 0.933. What did they do next out of curiosity? We're going to change ours. Oh, they actually, oh, well, that's quite brilliant. They actually just loop through and try several different Ks until they find a winner. They're machine learning on their machine learning. This is awesome. So we got all meta. Here you see, we have some winners. If you look at this, we could see that if I'm drawing here, the best outcomes were here and here. Well, I would choose, in this case, I would just take KNN3. That's going to be a faster, it's much faster just to look at a few. Obviously, if you get too big a set in a very small, we only have 50 total of each particular species. Getting up to 10, that seems a little excessive. I would consider the 7, but more likely I would stick with 3. I usually use the smallest number of neighbors that actually have, relatively speaking, good performance. All right, it's 12:34. What do you think? Was this worth working through? Did I help? Was it confusing? What do you think? Are people still there? Has the zombie apocalypse happened? So James, thumbs up. Dell, always worth it. I hope it helps. What I want you to see is that you can just get out there and find examples, go to Google Collaboratory and just start working through them. And Jessica, yes, play with it over the weekend. Have fun. There are literally hundreds of articles that all walk through the Iris dataset using different methods. Some even use neural networks. You can find, we could have run a quick neural network. Maybe we'll do that next time. The point is tons of examples to follow through, and that's a good way to learn things, just to play around with it and then make little tweaks as you go. I hope it was helpful. It's great to see you all. And Dell actually points out it'd be good to get more. I'd love for all of you to offer more either ideas for things for us to do, or just during the actual flow of our talk to actually toss out some more ideas, share insights that you have, or ask questions, whatever works that way. So I agree, Dell, it would be good to get more inputs. You included, Dell. You're not. And happy birthday to Dell. Yes, it's wonderful. Happy birthday. So it was good to see you all here. I'll see you next week. Next week we'll do images. We'll do some image processing and machine learning related to perhaps classification that way. So see you all later. I'll stop recording.